In 1989, Voyager 2 flew past Neptune, the only spacecraft that ever has. And what it recorded in those final seconds sent scientists into an emergency meeting at NASA. They expected a calm, distant, blue giant. What they found was something far more violent, far more wrong. In this video, 3 things about Neptune that most science teachers never mention. The first will change how you think about wind. The second involves a moon that Neptune shouldn't have. And the third is a recording from Voyager 2 that scientists spent years trying to explain. Neptune sits 4.5 billion kilometers from Earth. Light takes over 4 hours to reach it. We have sent one probe. And even that single visit was almost enough to rewrite our textbooks. Here is a fact that genuinely disturbed the scientists who discovered it. Neptune receives 900 times less sunlight than Earth. It is one of the coldest places in the solar system. Surface temperatures around -214 degrees Celsius. Now, what happens when you remove almost all heat from a planet? You would expect the atmosphere to go still. A dead, frozen world, barely a breeze. Instead, Neptune has the fastest sustained winds of any planet in our solar system. Winds that reach 2,100 kilometers per hour. A Category 5 hurricane, the most destructive storm in human history, maxes out at 280 kilometers per hour. Neptune's winds are 7.5 times faster, and they blow permanently. This should not be possible. Wind is driven by temperature differences. Temperature differences require heat. Neptune barely has a heat source. So where is the energy coming from? The honest answer, even in 2026, is that we don't fully know. The leading theory: Neptune radiates heat from its own interior. About 2.6 times more energy than it receives from the sun. Something in Neptune's core is generating energy. Something we have never been able to see directly. In 1989, Voyager 2 photographed a storm on Neptune called the Great Dark Spot, roughly the size of Earth. Winds around it measured at 2,400 kilometers per hour. When Hubble looked at Neptune in 1994, the storm was gone. It had appeared and vanished in 5 years. A storm the size of a planet appeared, raged, disappeared, before we even understood what it was. Neptune has 16 known moons. Most of them are small, irregular, and unremarkable. But one moon, Triton, is different in every conceivable way. Triton orbits Neptune backwards. Every large moon in the solar system orbits in the same direction as its planet rotates. This is because moons form from the same spinning disk of material that created the planet. Except Triton. Triton orbits in the opposite direction, which means only one thing. Triton is not originally from Neptune. Triton was captured. At some point in the ancient solar system, Neptune's gravity reached out and grabbed a rogue object. An object astronomers now believe was originally a Kuiper Belt object, similar to Pluto, and locked it into orbit. But here is the part that should disturb you. Because Triton orbits backwards, it is slowly being dragged inward by tidal forces. In approximately 3.6 billion years, Triton will come close enough to Neptune that the gravitational tidal forces will exceed the structural strength of the moon itself. Triton will be torn apart. The debris will form a ring system more spectacular than Saturn's current rings. Neptune will gain its rings by murdering a moon it kidnapped. But Triton is already doing something unexpected right now. When Voyager 2 flew past Triton, it observed something that forced scientists to rewrite the definition of geological activity. Geysers, active geysers. On a moon, with a surface temperature of negative 235 degrees Celsius, just 38 degrees above absolute zero, the coldest possible temperature in the universe. These geysers shoot nitrogen gas up to 8 kilometers into space. Solar radiation alone is enough to heat pockets of nitrogen ice beneath the surface, turning them into gas that explodes upward through the crust. On the coldest large body we have ever visited, there is active, violent geology happening right now. Here is the detail from the 1989 flyby that most documentaries never mentioned that as Voyager 2 passed behind Neptune and then Triton. The radio telescopes on Earth picked up something unexpected. Electromagnetic signals from Neptune's magnetosphere. Signals that scientists had not predicted and could not immediately explain. Neptune's magnetic field is tilted 47 degrees from its rotational axis. For comparison, Earth's magnetic field is tilted about 11 degrees, and that alone is responsible for the northern lights. Neptune's tilt is so extreme that the magnetosphere sweeps through space in a wild, spiraling pattern as the planet rotates. The result: Neptune generates electromagnetic patterns so complex that when converted to audio frequencies, the way NASA's Voyager team did, they produced sounds that many scientists in the room described as deeply unsettling, not supernatural. Unsettling because they were so complex, so structured, that they had no immediate physical explanation. Neptune's magnetic field does something else that no other planet in the solar system does. It rotates independently from the planet itself every 17.2 hours. Neptune completes one rotation, but the magnetic field doesn't follow. It sweeps through space in its own spiral pattern. The result: the radiation environment around Neptune changes completely depending on where you are in that cycle. On one side of the planet, the magnetic field funnels charged particles directly into the atmosphere. On the other side, it deflects them into space. This creates auroras on Neptune, but not at the poles. Not like on Earth, scattered across the planet, at random latitudes, moving, unpredictable. Voyager 2 captured images of Neptune's night side. It photographed glowing streaks of ultraviolet aurora dancing across the cloud tops on a planet where almost no sunlight reaches. There were lights. Here's what puts everything in perspective. Have sent orbiters to Jupiter, to Saturn, to Mars, to Mercury, to Venus. We have landed on the moon. We have rovers driving across Mars right now. Neptune has had one visitor, one in 1989, and the reason there is no return mission planned is not lack of interest. It is the distance. A mission to Neptune takes approximately 12 years of travel time with current propulsion. 12 years of fuel, 12 years of communication degradation, 12 years of spacecraft components slowly failing. NASA has studied Neptune orbiter concepts repeatedly. The most recent serious proposal, called Trident, was submitted for NASA's New Frontiers program in 2021. It was not selected. The next opportunity to propose a dedicated Neptune mission is 2026, which means even if it is selected, the earliest it could launch is the mid-2030s, and it would arrive sometime around 2045. Neptune is waiting. It has been waiting for 35 years. It will wait a little longer. Neptune sits at the edge of our solar system, barely explored, barely understood. It has winds we cannot explain, a moon it stole that it is slowly destroying, and a magnetic field so distorted that even our most sophisticated models struggle to predict it. And in the entire history of human spaceflight, we visited it once for 6 hours 35 years ago. There is no mission currently planned to return. Whatever Neptune is hiding, We may not find out for a very long time. If you want to know what would actually happen to a human body if we ever sent a mission to Neptune, the temperatures, the pressure, the radiation, the journey, that's the next video in this series. The link is on screen right now. And if this video genuinely disturbed you in the best possible way, subscribe. Every week we go to the places in the universe that most channels are afraid to cover in full.